Okay, fantastic. Hello and welcome. Hopefully you can all hear me and see me. This is a bit of a slightly delayed webinar today, but really exciting and interesting topic as we look at an eco-town project, Elmsbrook, and a case study into sustainability. We've got 4 speakers today. Emma from the BBA, who's a certification scientist. We've got Lewis from Bioregional, a program manager. Simon Horn, technical development manager from Stuart Milne Timber Systems. And Steve Hornblow, who's the head of special projects, Northwest Bicester, which is the actual project we'll be talking about today. And he's from A2 Dominion. So fantastic to have everybody on the panel. I'm just going to do my general admin and intro to the BBA, just for those people on the webinar that don't know who the BBA are. Apologies if you've heard this numerous times. I'll try and change it up maybe next time. So the BBA, we've been around for over 50 years, I think it's 55 now, helping construction and manufacturing industries build confidence in the design, the creation, the implementation, the innovation of products and services throughout the entire supply chain. We look to develop long-term partnerships with our clients, and that's to help continue growth both in the UK and in global marketplaces. But it's important to remember we will always remain reassuringly impartial. The BBA is actually a for-profit organisation limited by guarantee. So what the BBA looks to do is reinvest what they make in the industry as a whole for all the stakeholders involved, which includes you and I and the wider community or the entire supply chain, like I said earlier. Brief intro to the BBA, what we actually do. Probably best known for our agreement certification or our product approval certification, or PAC, you might have heard it being called. That also includes reproduction certification, which is kind of like a white label certification, and HAPAS. We also do testing, audit and inspection, management systems, and more recently UCAS and UKTA markings and certification or conformity. So if you've got any products or services, then we're the chaps to speak to, basically. Just a few numbers on the screen to give you an idea of size. I'll focus on the 2 main large numbers there because they just sound better. Certificates issued to date, over 6,000, and annual inspections, over 1,000. We've got 130 people working for us, or over 130 people, all fantastic, amazing human beings that know their stuff inside out, which is great. But that's enough of the BBA. We're not here to talk about the BBA today. We're here to talk about sustainability. So what will we cover? We're going to cover what makes a sustainable building, very briefly, just as a bit of an intro to the whole webinar. Then we'll look at why the BBA certified materials matter from that perspective, again, very briefly, and then we'll dive straight into our case study, Northwest Bicester Eco-Time Project, which is called Elmsbrook. We'll have an intro to Elmsbrook, why it came to fruition and what it's all about. The actual project in terms of its sustainability, the makeup of the eco-town, and also what makes a project sustainable. So we'll cover a load of things today, and we'll finish with a Q&A. So it's a good time to say, if you have got any questions, please use the question functionality to ask your questions, and we can answer them at the end of this webinar. That's enough of me talking and introducing everything. I want to dive into our speakers today and let them carry on with the rest of this webinar because they're far more knowledgeable on this subject than I am. So the first person we're going to hear from is Emma Franklin, certification scientist at the BBA, and she's just going to very briefly introduce what makes a sustainable building and why a certification is important. So Emma, over to you.
Thanks, Peter. What makes a sustainable building? How long's a piece of string? Unfortunately, there's no just one answer for that. So a sustainable building, sustainability is one that considers the needs of the people and the environment now and in the future. It needs to be economically viable to build, to run and maintain, because that's the society we live in. Everything revolves around economics. So sustainability in all aspects. It sounds simple, but in reality, balancing all the three elements is often tricky, and there's no perfectly sustainable building because compromises inevitably have to be made, and people have to use their judgments to decide on what's the priority at the moment. Clearly, with the 2050 net zero targets, the embodied carbon is quite a hot topic and it's important, but considerations should also be used to given to other impacts. So the energy consumption of the building when it's in use, as well as embodied, fresh water consumption during manufacturing of the products and in use, other resource uses, waste, indoor air quality. There's a lot of things to consider. And then the building should also be looked at not in isolation, but as part of the local environment. The local climate and the orientation of the building can have a great influence of the design of a sustainable building. And then in addition, what about future climate? Is there potential for increased rainfall and localized flooding? And if so, then the design should mitigate against these. So the design of the building and the local environment. What about the occupants? If it's a high-tech building, do the occupants know how to use it as it's intended? Are there local transport links, or is private transport the only option? Is it a place that people want to be? An empty building is not a sustainable building. Okay, I can't see the slides, but never mind. Next slide. Ah, there we go. So BBA certified materials, why do they matter? So a BBA certificate provides accurate, reliable information so the building professional can be more confident in the decisions that they make. During the assessment of a new building material, the BBA reviews and verifies the evidence that has been provided to support the claims that the manufacturer makes. This could relate to the thermal or fire performance of the product, for example, or structural elements such as compressive strength. As the correct installation of the component into the building can be as important as the manufacturing of the product, guidance on the best practice when installing the product is also included within the certificate. This independent verification process reduces the risk of the product not performing as it should when installed into the building. This in turn reduces the chance of building and component failure, leading to replacement earlier than planned, and in the case of insulation, a greater in-use energy consumption of the building than predicted. And then over to Lewis to look at the aims of this particular development and whether it actually achieved the aims, because I'm really curious to know.
Thank you, Emma. Thanks for that brief intro. Yes, like Emma said, it's over to Lewis, the program manager from Bioregional. I'm sure he'll do his own introduction. I'm going to hand over to Lewis. So if you just give me 1 second, you'll have control round about now. You should do, so you should be able to present on your own screen.
So yeah, I'm just going to give a really quick introduction to Northwest Bicester, Elmsbrook, and I'm just going to give a really quick introduction to sort of myself and also Bioregional. So yeah, my name's Lewis. I'm a program manager with Bioregional. We're a sustainability consultancy, charity, social enterprise. I've been with the organisation for about 9 years now. There's a lovely sort of aerial image there of Elmsbrook. We're actually based on site as well. I'm actually there as we speak. So a little bit about Bioregional. Founded sort of over 25 years ago. There's our chief exec, Sue, speaking about the UN SDGs Eco Build a few years ago. We're probably most famous for a number of things, but our One Planet Living framework, that stemmed from the creation of BedZ down in South London, which many of you will be aware of, which is where our headquarters is. And the One Planet Living framework is a sort of sustainability strategy that we use to engage with a whole range of different partners. Who do we work with? We work with a whole, as I said, a whole range of different partners. You can see here on the left, we work with large corporates with their sustainability strategies, targets, science-based targets and things like that. Crucially for this particular webinar, we work in the built environment. So we work with a whole range of developers, be they sort of small innovative ones, but also much larger developers and house builders as well. And then we also work with, on sort of right-hand side there, we work with sort of public sector, be they local authorities or be they more sort of central government departments such as Homes England. So just really focusing on the sort of built environment side of things. So we work on a whole range of different schemes. This just gives an example of some of the different schemes that we've worked on over the past sort of 5-6 years. So fairly large sort of urban extensions, much smaller sort of innovative, ambitious schemes, flatted city centre locations such as in Brighton and also over in Galway, but also you can see there in the bottom left a nice image of Elmsbrook Bicester, which I'll be touching on in a minute. I couldn't do a presentation about Bioregional, One Planet Living and sustainable construction without showing an image of BedZ. Hopefully all of you will have known about this scheme, built in the early 2000s. It's sort of often thought as the UK's first attempt at a sustainable community, and it was developed in partnership between ourselves, the Peabody Trust, Bill Dunster, architect in the Z Factory, as well as a whole range of different consultants as well. It's 100 homes, mixed use, based in the London Borough of Sutton in Hackbridge, and it's where our headquarters are. And you can see that sort of a lot of the sort of visual sustainability coming through there, such as the passive ventilation wind cows, the solar PV, the solar PV tiles, as well as the film, and the sort of sky gardens as well. So just a really quick bit about One Planet Living. The concept of One Planet Living comes from this problem here, which is the fact that we're actually consuming resources in far greater than our 3 planets. So here you can see we're actually in line with 3 planets here if we lived as we would in most of Western Europe. Other parts of the world have significantly more, but also other parts have significantly less. You can see here our sort of a typical lifestyle in the UK is made up of those different facets there. So energy and transport making up about a planet's worth, food and the stuff that we purchase, our goods, making up a second one, and our 3rd planet is made up around the services, the government, and the sort of capital assets that we have. Clearly that's not sustainable. So a lot of the work we do is working with our partners to understand resource consumption, and this in a nutshell is the 10 principles of One Planet Living, and it's how we use to engage and start that sustainability strategy with all of our different partners and stakeholders. So ranging from health and happiness all the way through to some sort of fairly obvious concepts such as zero carbon energy, zero waste, and travel and transport. And the way that we embed One Planet Living is pretty much follows this flowchart here: local needs analysis, understanding what is the context, developing sustainability objectives, and then that usually comes out as a sustainability brief. We then look to turn that brief into an action plan by developing indicators and actions through design workshops. And then what we like to do is we like to obviously formalize that into planning by creating a sustainability statement, but we then also like to work post planning and into the construction stage as well, which is what we've done on Bicester, through the role as what we call a One Planet integrator. And we also do POE and monitoring as well, which we've done for a couple of years in Bicester. So just really quickly, I'm going to just touch on a number of the sustainability elements as a overview of Northwest Bicester. So where is Bicester? Hopefully some of you will have heard of it, but it's a growing market town just outside of Oxford with very large housing targets, approximately 13,000 new homes planned across the local planning period. It's about 10 miles from Oxford. It's very well serviced by rail links, both north and south, up to Birmingham into London, but also east-west to Oxford, and hopefully in the future over to Cambridge. It's built around an eco-town vision, which is about an extension to the existing town, with a vision to make all of Bicester an eco-town. So very much not a sort of standalone development. Here's some sort of OS maps. So you can see back in the 1950s, not a lot in Bicester, a sort of fairly linear settlement pattern there around the main road and a sort of a traditional market. Then you can see post-war, moving into the sort of late 90s, early 2000s, it really started to grow and has grown significantly around those transport links, which, you can see sort of transect sort of east-west, but also sort of north-south as well. And this is an image of some of the growth areas happening within Bicester. So Bicester 1 at the top of your map is Northwest Bicester. And I'll do a little zoomed in image to show where Elmsbrook is. You can see Bicester 2 down to the south, that's the Graven Hill scheme. That's one of the largest self-build developments in the UK, built on an old MOD site. So you can see some very substantial housing growth happening across the town. And so Elmsbrook at Northwest Bicester was built around the eco-town concept, which came out from New Labour in the early 2000s, around how we can build large-scale developments sustainably. Bioregional were involved in the creation of sort of setting what this standard would be. For the sort of planning nuts out there in the audience, this was a planning policy statement. So this is pre-national planning policy framework. This actually set specific standards for what an eco-town should look like, of which Northwest Bicester is one. So you can just see I've just mentioned some of these here. So around true zero carbon, high water efficiency, reducing the embodied carbon of construction, particularly important for today, zero waste to landfill, net biodiversity gain, etc. That planning policy statement has now been revoked due to the sort of changes in the sort of national planning frameworks. However, these standards have been ingrained in the Cherwell local plan. So Cherwell is the district within what Bicester sits in. So a lot of these are still being aspired to and met. So where are we? Sort of over 12 years on now. Still a designated eco-town. Bicester also has garden town status. It's also one of the 10 new NHS healthy new towns, so has a number of different labels. As I mentioned, Northwest Bicester is not just about a sort of discrete eco-town. It was also around how the ripple effects of sort of high quality sustainable development can be felt within the existing town as well. So there's a portfolio of town-wide projects ranging from reuse centres to sustainable transport initiatives, and also retrofit programs. There's a master plan for the entirety of what you saw there, Bicester 1, which is Northwest Bicester. The exemplar, the first phase, which is called Elmsbrook, is being built out, almost completed. There are a number of outline applications for some of the further parcels within Northwest Bicester. There's a new rail underbridge and underpass, as you can see in that image there, just put in earlier this year, that helps to unlock the wider scheme. That's sort of a very crucial bit of major infrastructure. And we've tried to use One Planet Living as a way to kind of structure Elmsbrook development response to sustainability, and with that, a number of research projects have happened over the sort of past decade from the Department of Energy and Climate Change, as was now BEIS, but also Innovate UK. So just burrowing down, I've got a couple of slides here just on sort of Elmsbrook. So there you can see the red line for Northwest Bicester, that allocation of about 6,000 homes, and the yellow line there you can see is the exemplar boundary, or what we call Elmsbrook. Steve later on will go into sort of far more detail about that. So just as an overview to some of the sustainability principles, so Elmsbrook is just shy of 400 homes, has a primary school, has an enterprise hub, which is what I'm sitting in today as I speak to you, and a local centre just being developed now. It is part of that vision for a 6,000 home master plan. Has been occupied from phase 1 from about 2016 onwards. Has a zero carbon strategy, PV on every roof when Elmsbrook is completed. Reportedly will be the largest domestic solar array in the UK. Has a concept called the Shimmy, which is an in-house app giving real-time information such as public transport, but also monitoring of energy and water. It's again, the other two speakers will go into far more detail about this. So use of MMC timber SIPs at a large scale, which is all part of the sort of net zero carbon strategy. Some of the other wider sustainability principles, so 40% green space within Elmsbrook, with the inclusion of community orchards and some community growing areas. There's a community bus from first occupation that you can see there in the top left, that image. Really high quality walking and cycling routes within the development. Electric charging points, both for residents but also in the public realm. And a real strong push for electric vehicles within the residents, with a higher than the average for Oxfordshire uptake through sort of concepts around EV champions. And yeah, at the top there you can see one of the community growing spaces there. Yeah, it has the UK's first Passive House Plus non-residential building. You can see there on the right, that's where I'm sitting in the top left hand of that image. To encourage home working is all part of the sort of sustainable transport strategy about minimising the need for people to travel. All of the homes are within 10 minutes of local facilities, such as a school, and 5 minutes of a local bus stop, with a range of supporting sustainable transport initiatives such as that bus, really good walking and cycling routes, and a Brompton hire scheme. Yeah, and as I said, the local centre is well on its way. On the sort of land use side, net biodiversity gain through the retention of the hedgerows is a sort of key master planning tool. The creation of sort of enhanced buffer zones around the hedgerows, waterways, and small woodland areas, but also the creation of new habitats such as the meadow roofs and also wildlife areas around the suds. You can see the outside gym there, but also the restoration of the local river corridor as well through the middle of the site. And yeah, Peter, that's sort of me. Hopefully gives you a really good overview of sort of Bicester, but also Elmsbrook.
Fantastic, thank you so much, Lewis. Yeah, fantastic overview, and we're going to start to go into a little bit more detail now as I hand over to Simon Horn, Technical Development Manager at Stuart Milne Timber Systems.
Good morning, everybody. Okay, yes, I've got a briefing presentation here on our solution and our build system that we provided to the Bicester Eco Village for A2 Dominion. And I'm going to walk you through just a few slides about that off-site manufactured timber frame product that we provided. And so similarly to Lewis, a couple of aerial views there of one part of the development. It's an off-site manufactured build system using timber frame construction. It's very much, we refer to the expression, a fabric first approach, and getting that performance through the external wall and through the roof and through the floors. So it's about the specification of the fabric and the solution to that. Additionally, to go with that, there was the product certification for that build system that we wanted to invest in, so that it was backed by an accredited body and gave substantiation to the performances that we were proposing. So you can see on the left-hand side there some of the accreditations and the image that was on at the very opening presentation as well, with regard to the actual BBA certificate for the Sigma 2 system. So the Stuart Milne Timber System Sigma 2 is a closed panel system. We went through, as it says, an extensive testing program for acoustics, for structure, for thermal, and for fire as well. And developed up a closed panel system that is a fabric first, but a fit and forget, because we know what that performance, like I say, is going to do. In getting the BBA certification to go with it, it's then regularly audited through manufacture, through design, and through construction, with surveillance reports being completed, I'd say, at each area, so through design, manufacture, and then the construction piece as well, to make sure that it is still being delivered and designed and manufactured in accordance with what the BBA certification has given its accreditation to. Additionally, robust details, you'll be familiar with robust details. So Part E of the building regulations and the resistance to the passage of sound. We wanted to demonstrate that we were as good as, if not better than, robust details. Robust details themselves set their own stall out that stated a 5 dB improvement over building regulations and Part E, approved document. We looked at those junctions. We've developed up our solutions to those junctions with products within the specifications of robust details, and then did our own on-site testing. And we've improved on that 5 dB improvement. So acoustically, the units are very, very strong, with scores of 8 to 10 dB above building regulations. So an improvement over the 5 dB requirement that robust details have set themselves at. And then lastly, thermal detailing. So Part L 2010, quite a monumentous update to Part L at that time, with thermal bypass, which was basically air tightness, thermal bridging, and obviously improvements on U values as well. So the accredited construction details came along, and it was a case of, okay, psi values of the individual junctions. They identified 15 junctions around the building to measure heat loss through. We know what it does through the fabric, but when there's the coming together of walls to floors, and then floors to walls, and then walls to roofs, what's the thermal performance between the junction because of the mass of material that is likely to occur at that connection? So the 15 junctions that were located or identified within the ACDs, 3 of them were the window jamb and head of a window, but the rest of them were those junctions I've just been describing, and then separating walls as well. So we went off and modelled them all. So all the psi value junctions were then modelled, and so that we could establish with some confidence what the Y value calculation was that they could be put into the SAP calc as well. Off-site manufactured timber frame closed panel. It's about quality of product. And like I say, we've invested in that BBA certification to back up what we are proposing, designing, manufacturing and delivering. That's our dedicated facility up in Witney, Oxfordshire, which is about 23 miles from the site at Elmsbrook in Bicester. That's a dedicated off-site manufacturing facility that's really driven by a CAD/CAM process. So drawn in computer to get efficiencies, reduce the amount of waste in the building before we even hit site, with a reduce, reuse, recycle policy. The software goes through an optimizer program. So from a yield of timber that comes into the factory, we're running at about 3.8% waste. But that 3.8% of waste is timber waste, so it can be recycled. So a hugely strong, environmentally positive building system by using timber. The other images there you'll see, like I say, it's an automated process. There's efficiency during manufacture of the product. Embodied carbon is about the sourcing of the material, the production of the material, and the transportation and shipping of the material. Our process is very lean, okay? So we have an automated, you can see there's not many operatives in those images. There's operatives at the stations, but there's automated stations. So we blow in insulation. You can see the insulation hopper that's over the panel. We blow in insulation. That's a recycled glass. It's a closed panel. We pre-fit windows into that closed panel system. We have an NHBC approval for that process as well. And then we go out to site on articulated vehicles. So that's about the biggest impact on footprints is in the actual haulage to the site. On site, it's an advanced form of construction because it's an assembly of components rather than a build, a construction of components. So we assemble from a foundation the wall panels, the floors, the wall panels, and then the roof on the top as a system build. It's platform construction in the UK. We work up within the four-sided scaffold that would be provided. And again, that's driven by health and safety and driven by efficiency on site as well. The Sigma 2 closed panel system that we've developed and supplied to A2 Dominion's project. There's an image of it top right there. It's an insulated closed panel with a dedicated service void pre-fitted in the factory. You can just about see, I appreciate the photograph is small, but you can just about see two black lines on the end of the panel coming towards you. That's the air tightness junctions and detailing. I'll come on to that in a bit more. Windows pre-fitted, like I say, fully filled with insulation. So it's ready for first fix services to take place on site, and it's ready for fitting out externally with whatever the cladding may be. Floor cassettes, we'll make them as large as we can. Again, efficiency of program, efficiency of build, and certainly efficiency of design and reduced material consumption. First floor wall panels then repeat. It's a platform construction, walls, floors, walls, floors, walls, roof on the top, as high as the building goes. With regard to the roof, and again, we majored on this with regard to ground level erect because of health and safety benefits. So there's no men and operatives working at height. We frame on the floor and then lift the roof on. And this is now our preferred build method for the roof phase or the roof elements. And we call it ground level erect. So we erect the roof on the ground and then lift it into position. A couple of images there of, firstly, again, Elmsbrook from the air, and then an example construction program. And this is about benefits now and an off-site manufactured timber frame system and the benefits it brings over and above a masonry brick and block sort of method of construction. So you can see top right hand corner, the program basically is about 55% shorter on a build program for that typical example that we've shown there. So we've done the time and motion studies on site to capture the efficiencies and the benefits of using timber frame, but also using an advanced form of timber frame with a closed panel system. With regard to measuring the carbon and during construction, and compared to masonry, there's a 30% reduction in the amount of carbon footprint by using off-site manufactured timber frame. With regard to that project in particular, 79% of work packages, ourselves included, were local to the site within a 50-mile radius on that site. It was one thing, having that tag of an eco town, it was from day one, it was all about the performance through the design, the construction phase, the manufacturing. It was all about being efficient, energy efficient, and energy conscious. So we were, like I say, we were only 20 miles up the road, basically, with regard to that 23% local labour. You can see the extent of PV on the aerial photograph there that was used as a renewable technology. So yes, it was very much a fabric first approach, but equally it was then underpinned by renewable technologies on the project as well. So you can see the extent of PV on the roofs. I remember at the planning stage, and I'm sure Steve does as well, the planners were very sensitive to extents of PV, and we had challenges sometimes on the orientations of roofs with regard to the extent of the PV that we were proposing because of the location outside Bicester, deemed as rural Oxfordshire. The planners were sensitive to huge swathes of PV everywhere, and how can you deal with this? So as you can see, it was very sensitive where it could be, let's say. But that gave then a contribution back to National Grid, as you would expect, because of the performance of the PV panels. So our fabric for Sigma 2 closed panel PBA certified offsite manufactured timber frame system and all of that. Okay, so left hand side, you can see it's a structurally broken and thermally broken stud. that frames the external wall panel. It's a closed wall panel, so it's closed off from the inner face with an inner leaf of OSB. And there's a dedicated service void with those pre-fitted service patterns. You saw that on the photograph a minute ago. So that's ready for first fix. Cable drops, pipe runs, again, very efficient to be then fitted out. Benefit that then gives you, you're putting those services into a dedicated service void, not into the fabric of the wall. Okay, so penetrations that are coming out from the wall and into the dwelling are less intrusive to the wall, and therefore better air tightness. The values of U value through the fabric, 0.15, those psi values contributing to the Y value that went into the SAP calc, 0.04 for the thermal bridging, because you can see the only bit that passes from inside to outside is the web of the double stud. So the double studs are joined by a timber web that is an OSB web from inside to outside. That's the only bit that's transferring through mass any heat loss. Hence, we're down at the enhanced construction details. So the accredited construction details came out 2010, not long followed by the Energy Saving Trust's enhanced construction details, which lowered the values down again. Building regulations at the time was 0.08 for thermal bridging. We halved it and down to a 0.04 on its thermal bridging value. Air tightness, again, the requirement was 3. You can see bottom right-hand corner, this is a busy slide, but bottom right-hand corner, average pass was a 2.65 on our air tightness. So we improved over the performance requirement for the project, which was a 3. And again, some other sort of just minor details on here. So the isometric wall junction of separating wall to external wall, you can see that we had a separating wall that was an insulated separating wall. So again, back to Part L 2010 and thermal bypass, at that time, an uninsulated separating wall cavity was a U value of 0.2. By adding the insulation to the cavity itself between the panels, U value of 0. So again, thermal performance benefit to the overall building, and back to that SAP calculation. The C-stud, excuse me, the C-stud, as we refer to it, has a C-stud bottom rail of the panel that saddles over the inset sole plate. So again, you are reducing the build-up of timber at the connections of the wall panel to the foundation and then the wall panel to the floor above, because it's the same principle. The C-stud is also then the bottom rail and the top rail of the panel. So it saddles over the sole plate, and you can see the air tightness foam that is applied before we land the panel, gives that an air tightness seal. There are those 2 black lines again, the air tightness junction between 2 panels. Bottom right-hand corner, the air barrier pre-fitted around the floor cassettes in the factory. That then laps with the inner face of the external wall by dressing it up and dressing it down below. So you get an air tightness performance and an air tightness barrier that comes up the external wall, laps around the floor cassette, and then carries back on up the first floor external wall. So, like I say, air tightness performance was very strong on the project. I appreciate, again, the photographs are small. The U values there, between the studs, 0.149. We wanted a 0.15, so we were just under it. And then equally the whole wall and on the studs for the timber fraction there as well. And those are the actual percentage of bridging values that we achieved. So the embodied carbon result and what that benefited when we did this analysis based on a terrace, basically, again, comparing it back to masonry construction for our Sigma 2 closed panel system, and some of the benefits there without going through all those facts and figures, the 3 headline figures down the left-hand side are the important ones, particularly the one in the middle versus masonry construction, and the need for us to build more smartly, more sustainably as we move forward with the challenges of net zero 2050, gas going from new build in 2025, and how do we heat homes and how do we retain that heat? How do we improve on our footprint and our embodied carbon for our material and productions, processes and our construction? All of those were positive results using our Sigma 2 closed panel system. And then just a few images. It was a really nice looking project, good use of materials, again themed as rural Oxfordshire, but nice use of timber claddings. This shows you the flexibility of timber frame construction. That timber frame is a skeleton inside that building, and that skeleton is doing the work structurally of live loads and dead loads down to foundations. And it's also doing the work thermally and acoustically between the dwellings. But a nice usage of materials. We've got stone, we've got render, we've got timber, and some really nice looking street scenes. The top left hand corner you can obviously see they were some flats, flat on flat, 3-story flats with external balconies to create outside areas, etc. So a very successful project and one that did deliver. Thank you, Peter.
Thank you, Simon. That really interesting to go into mega detail in terms of what makes up a sustainable building environment, really, which is really cool to see. So thank you so much for that. I'm just going to make sure that I'm sharing my correct screen. So 1 second. Yeah, brilliant. I think I am. Right. Okay. Final speaker for today. I know we're slightly behind time. But I'm going to pass straight over to Steve, who's going to take you through delivering the future today. Steve, over to you.
Thank you very much, and thank you for the other presenters of presenting the scheme so well, and the scheme that I've been involved with right from the beginning. It's been 12 years now that I've been involved with this scheme. So next slide. So who are A2 Dominion? A2 Dominion are a housing group. We've got about 36,000 homes in ownership. We've got a development pipeline of about 4,600, and we develop out around about 1,500 homes per year. Our business model for that is we buy up land like Northwest Vista, and we build those developments out, and we sell the private sale for as much profit as possible, and then we reinvest that profit back into the affordable side of our business. So all the profits that we make go back into affordable housing. And of that 30% affordable housing at Northwest Vista, we will be the landlord of the affordable housing forever. So we're not a developer that just builds and disappears. We're there for the long term, and there's a need to invest in quality and life cycle costs within those properties, because we own 30% of the homes at the end of the day. We're not a developer that disappears. So I'll whip over these quite quickly because I think we've talked about most of these. First eco town in the UK. It is the only one of the original 4 eco towns to meet the full eco town principles. It's part of the Healthy Town scheme, which go on to the next slide. It's the only development in the UK to meet true zero carbon. And what we mean by true zero carbon is we include for the regulated and the unregulated home. Most definitions of zero carbon only include for the regulated energy. So the unregulated energy is the energy people use living in the home, not just the SAT calculations. And that's why we call it true zero carbon, because it is the true picture of people living in the homes. So it's the energy that they use powering their laptops, their appliances and everything like that. And it makes us around about 30 to 40% above zero carbon. So quite a challenging target. 30% embedded carbon, we've already talked about. Zero waste to landfill as well. And the homes have been designed for future proof. So we've got a weather set for the scheme for 2050. So we're predicting what the weather is going to be in 2050, then using that in all our design calculations to make sure that the homes are cool in the summer and warm in the winter, and we resolve issues like flooding and drainage has been increased in subsystems and everything. We do sustainability for us means a lot of things. It's not just about energy, it's about transport, it's about communities and how people come together. So as Lewis has already sort of said, we've done a lot of work around the modal shift targets of the scheme. So we've got a target to achieve 50% of trips from the site to be by a sustainable mode. So we've done lots of work with the residents and put in the infrastructure to allow that, so allow electric charging, to allow cycling. We've got a Brompton bike scheme and many other things just to make sure that that all comes together and works long term. Then sustainability for us is not just about sustainability, it's about well-being. Sustainability and well-being go together. They're the same. So we've created the UK's first heart safety community on the scheme. So every bus stop within the scheme has got a defibrillator. So there's defibrillators within 400 metres of every home. We've got designed 40% designated green space, which we've designed to a lot of community allotments in space that the community can use in well-being. It's important that we design in those spaces from the beginning, and the green spaces are just not an afterthought, but they are integral to the whole design. Sustainability and health are interlinked for us. So sustainable materials, and this was a discussion we had numerous times throughout the scheme all the way. And the way I can best describe it is it's a set of scales. There is always more sustainable products you can use, but then a lot of those, not all, but a lot have an increased cost. So on one side you've got costs, and then the other side you're trying to balance up what the embedded carbon is within that product, what the waste products are, the location, and renewable energy, and it all used during that process. So it all is a balancing act that needs to come together. In addition to that, you've got planning, and planners expect homes to look in a different way and use different materials. Not only the planners, but even the engineers. We tried to get solar lighting into the scheme, but the county council wouldn't allow us to do it because it wasn't a standard product that they would maintain in the future. So there's lots of expectations and bits that you have to try and balance. And we almost went through the scheme item by item, looking at the various big items and seeing if there is an alternative that can be used that is within budget that increases the embedded carbon or has lower waste or is coming from a more location that is more sustainable for the scheme. And we've done a lot of work, as we said previously, about working with local suppliers to make sure local suppliers, so the timber frame comes from 25 miles away, or the windows come from a manufacturer that's actually based within the site. And we had lots of different materials that we used that were local and provided what we need. One example of this is, next slide, Beckstone. Beckstone was a product that was introduced to us. It's manufactured over by Burford, about 25 miles away from the scheme. The manufacturing process in the factory they've got there has got wind turbines. So they're using that wind turbines and that electricity in the manufacturing process. So it's using renewable energy. There's low levels of waste from the product. It's a reconstituted stone product. And then at the end of the day, it was cheaper than anything else we could find at the time. So it was a complete win-win situation for us. We got a product that met their expectations of the planners, looked good from a sales perspective, was environmentally friendly, and the costs work. So it was trying to find those win-win situations all the way through the scheme. And you can't do it on every product, but where we could, we tried to use the best product for the scheme. So what's at the end of this great exemplar scheme? What has it meant? Well, it's what it's come down to. We do monitoring year by year, and we're showing now that our residents are using 40% less electricity per year. So it's quite a substantial saving in electricity from our residents using the solar panels. In addition to that, they're saving 61%. It's not the 41 shown on the slide, but 61% energy usage on the home against a typical property in Bicester. So our residents are saving quite a bit of energy across the scheme. In addition to that, the health and well-being side of it is equally important to us. So we've got a third of residents that know 15 or more other residents. So that's important for us to make sure that we are creating communities. A2 Dominion has a social purpose, and it's all around placemaking and creating communities. So this is an absolute great result for us to come up with this. I mean, 65% of residents say that they feel healthy. Again, it's great news to know that our people within our developments are community focused and enjoying living in that community. These figures were done pre-pandemic. We've just done the figures for the lockdown period. And then what I've got to say, what I saw from the scheme was that it would be more, the percentages are going up because the residents really came together in the pandemic, and it was lovely to see the residents talking to each other and supporting each other. So that's sort of Northwest Bicester from beginning to end.
That's fantastic. Thank you so much for that, Steve. Really interesting to, especially what you were saying there, that the last part, the community part, and having that togetherness is, I think, something that we don't really associate with sustainability or building nowadays. So it's really cool to see that come to the front. Excellent, thank you. Well, thank you everybody for joining us today. I know we're way over time. We're a bit short of time for questions, so I'm just going to wrap this up now. I'm not going to go to Q&A, but if you have got any questions, please still send them in. Please email us and I can find out the answers for you and send them back to you directly, because that's what we want to do. We want to help everybody that's on this webinar today. So final summary from me, goes without saying, thank you so much to everybody that's joined us today. Very much appreciated. Next week, we will have a look at the BBA client portal. So if you're interested in that, please join us, please sign up for it. Links are on the website. Finally, thank you, Lewis. Thank you, Emma. Thank you, Simon. Thank you, Steve. Absolutely honoured to be with all four of you today. And it's very much appreciated you've taken the time out to speak to everybody today. So thank you so much.
Thank you.